You know, we hear a lot about data and statistics, but what really separates the basics from a master's level? We're going to pull back the curtain and see what it actually takes to earn that advanced degree. Let's dive in.
So let's forget the textbook definitions for a second. What's actually on the test? What kind of problems do you have to solve when it really counts? That's what we want to know, right? And to figure that out, we're not just going to talk theory. Nope, we've got the real deal. An actual final exam paper for a Master of Commerce in Statistical Analysis. So let's break this thing down, piece by piece, and see how a real stats expert is made. All right, so where do we even start? Well, the first big thing they test you on is how to turn total chaos into clarity. Before you can find any of those amazing insights, you first have to get all your information in order. It's the foundation for everything else.
And you know what one of the most basic tools for that is? The questionnaire. Seriously, the very first question on this master's level exam is just define it. That's because it's the absolute starting point, right? It's the bridge that takes you from a question you're curious about to the raw data you need to actually answer it. But here's the kicker. The exam doesn't just ask what it is. It asks what makes a questionnaire good. And honestly, this is so important. Because if your questions are confusing or biased, all that data you collect is pretty much worthless. You've heard it before, garbage in, garbage out. It all starts here. Okay, so let's look at a real problem from the exam. You get this list of percentages about smoking habits in 2 different towns. And the task here isn't some crazy hard math. It's about organization. It's like a puzzle. You have to take this mess of numbers and put it into a clean, simple table so you can actually compare town A and town B side by side. Makes sense, right? All right, so once your data is all neat and tidy, the fun part begins. This is where you put on your detective hat. You start looking for clues, patterns, connections, all the stories that are hiding just underneath the surface of those numbers. And that brings us to a really interesting question from the exam, something super relatable. Is there a link between a student's age and how likely they are to fail? I mean, that's a huge question, right? It could affect how schools work. And statistics? Well, that's the toolkit we use to find out. So this is the data they get. Just take a look. It's kind of hard to tell what's going on, isn't it? The failure percentage goes up, then it goes down, then up again. You can't just eyeball this and know the answer. You're going to need something a little more powerful than just your eyes. And that tool, it's called correlation analysis. Basically, it takes you past a simple gut feeling. It measures exactly how strong the connection is and in what direction. It boils it all down to a single number that tells you the real story. It's all about finding that signal in the noise. Okay, so we figured out how to understand the present. Now let's talk about predicting the future. This is where statistics gets really cool, almost like a crystal ball for businesses, helping them figure out what's coming around the corner. Think about it. Business is all about uncertainty. It's a series of bets. Will this new product sell? Is the market going to go up? Probability is just the math we use to put a number on that uncertainty. It doesn't make the risk disappear, but it lets you measure it, manage it, and hopefully make smarter bets. And this exam problem is a perfect example. You've got 4 students trying to solve one problem. Each one has a different chance of getting it right. The question is, what's the probability it gets solved? And it's not as simple as adding up their chances. You have to figure out the odds that at least one of them succeeds. That's a core idea in managing risk for, well, anything. But forecasting isn't always about, dice rolls and grand predictions. Sometimes it's about filling in the blanks in your own history. Like, what if you're a company and you're missing the sales report for one specific year? That's a huge gap. How do you figure out what goes in that blank space? Well, this exam question gives you exactly that problem. You've got profit numbers for all these years, but 2019 is a big question mark. The job is to estimate it using a method called interpolation. You're basically using the numbers you do have to make a really smart guess about the one you don't. And you need that, right? You need a complete picture to plan for the future. Okay, let's recap. We've collected our data, we've found the hidden connections, we've even tried to predict the future. So what's left? Well, the final, most important step, making a decision. This is what it's all about, turning all that number crunching into a real-world action. Okay, put yourself in this situation. You're running a political campaign. You get a pollback that says you're winning, 51 to 49. But is that 1% lead real? Or is it just a fluke, just random noise, because you only talked to 400 people? I mean, everything could ride on that answer. And yeah, you guessed it, this is exactly the kind of high-stakes problem you'd find on the exam.
The tool you use for this is called hypothesis testing. And honestly, the best way to think about it is like a courtroom trial for your data. The starting assumption, the innocent until proven guilty part, is that the race is a dead heat, 50-50. Your poll result, that 51%, is the evidence you present to the court. Hypothesis testing is the process that decides if your evidence is strong enough to overturn that initial assumption and say, yes, we're actually ahead. So, hypothesis testing is awesome when you have some data to test. But what happens when the future is a complete unknown? When you don't have probabilities, you just have a few different ways things could turn out, and you still have to make a choice. That's where something called a payoff matrix comes into play. And yep, it's another problem from the exam. It looks complicated, but it's pretty simple. Each row is a different strategy you could pick. Each column is a different version of the future that might happen. And the numbers inside, that's how much profit you'd make in each scenario. So, which row do you choose? And here's the really fascinating part. The right answer? It totally depends on whether you're an optimist or a pessimist. The exam actually makes you solve it both ways. There's the maximin way. That's for the pessimist. You look at the worst thing that could happen with each choice, and you pick the best of the worst. But then there's the maximax way. That's for the optimist. You just look for the single biggest possible win and go for it. Same data, totally different mindsets, and potentially totally different decisions.
So, after walking through this master's exam, what have we learned? It's pretty clear that advanced statistics is way more than just doing math. It's a whole framework for thinking. It's about how you gather evidence, how you find the story in the data, how you deal with uncertainty, and how you make a solid choice. Which kind of leaves you with one big question, doesn't it? Is statistics just about math, or is it really the art of making smart decisions when you simply don't have all the answers?